hope all of us are doing fine. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. Now, before you proceed, I can like to request our members to be subscribing to our channel. So go to YouTube, search Ernest Sciences and Mathematics TV channel. Subscribe, engage us in the comment section, and also ring that notification bell to be getting updates on our various discussions in math and sciences. Now, in this particular discussion, we're going to look at the concept of the radius of gyration. And of course, this is going to be assisting us in trying to find the distance or the radius with which, of course, this specific aspect of machineries or other equipment that are going to use this specific concept are going to rotate. And of course, we're going to see that in our day-to-day applications, we're going to see this one being exploited in the manufacture of machinery such as pumps, engines, and turbines. And of course, we're going to see that this specific equipment are going to be having what we call the moments of inertia. So in this case, we're going to see that what I've basically mentioned in this case for the turbines, engines, and pumps, they are going to be having this specific aspect of rotating machinery, which of course is going to be having this aspect of the moment of inertia. Therefore, we are going to consider this specific radius at which we're going to consider the mass to rotate as the radius of gyration. And of course, we're going to have a way of representing the moment of inertia of this specific, of course, concept by having its element of mass and of course this radius of gyration. So in a sense, we can represent the moment of inertia of this specific, of course, application as the product of m and k, the square of k given as such, where we're going to have this m given as the summation of the mass elements given as such, which is going to be particularly forming what we refer to as our total mass. So in this case, we are going to have k representing what we refer to as the radius of gyration, whereby we're going to have this specific radius at which these machines, or we're going to consider the mass to rotate. So in this case, we can as well represent this particular aspect of the radius of gyration from this specific derivation, whereby we're going to have k represented as the root of the moment of inertia all over mass given as such. So in this case, we're going to consider particularly an area using these three specific illustrations for A, B, and C. So we're going to consider an area given as A in this first, of course, illustration with the moment of inertia given in terms of, so this basically is circular. So we're going to have the moment of inertia of A given in terms of this one. And of course, that is going to be represented from our previous discussion. We have said that this is going to be given in terms of dA. But in this case, we are going to consider this aspect of the radius of gyration, whereby we're going to imagine that this specific area is going to be concentrated in a strip that is parallel to either the x or the y axis, which I've given from my previous statement in this particular formula. And that is going to be assisting us in trying to evaluate the moment of inertia. So this specific area which is concentrated in a thin strip parallel to the x or y axis is going to be having an equivalent amount of moment of inertia, which I've given using this specific formula. Therefore, we can illustrate this particular moment of inertia with respect to x given as such by giving it as the product of m kx the square of that one, whereby we're going to consider this radius of gyration about the k, the x-axis given as that one. So this one will further have an implication that the radius of gyration with respect to the x-axis is given as the moment of inertia about the x-axis divided by the mass given as that. And similarly, we can have this specific moment of inertia with respect to y given in terms of m k y squared, still having the implication of this specific aspect for representation of the radius of gyration with respect to the y-axis given as that. So we're going to find other examples which are going to be exploiting this specific aspect of the radius of gyration. So in my subsequent videos, I'm going to be giving particular examples whereby we're going to either prove or evaluate as the different aspects of the radius of gyration. So kindly check our description boxes for various links of other videos. Subscribe and engage us in the comment section, and also invite more members so that you can form a large community of members discussing various topics and challenges in mathematics and sciences. So that is it for now, guys. Bye, God bless you. Catch us in our next video.